has a couple different aliases. Okay. Because there's a couple different ways you can go about getting this. Prime factorization is also known as AKA, also known as division by primes, and it is also known as factor trees. Or I like to call it the tree thing. All of these things pretty much mean basically the same thing. And what prime factorization is, first of all, the title should give you some clues. What do you suppose clues you're given there? First of all, the word factor. Let's look at that. What is where do we see the word factor? Factor comes when we do what? Oh boy. Holly? Right. Factors are the things that you multiply together to get a product. And the word prime, which we talked about, prime means what? Nate? No, what's the word prime mean? We just talked about something. We did a whole problem that dealt with prime numbers. What is a prime number? And let's go to Jack. Number that only has two factors. Okay, what prime factorization is, write this down, it is breaking a number down so that it is just prime factors, which will mean nothing to you but until you do one or two here. First of all, you cannot prime factorize a prime number because it is already prime. The only thing you can prime factorize are what we call composite numbers, which aren't prime numbers. I show you in just a second, because I see some of you are diligently writing down, as you should be. Let's start with probably the easiest. The first composite number we come with is 4. Okay. 4, if you were to prime factorize 4, it's very simple. 4 breaks down into 2 times 2. These are both prime numbers, and when you multiply them together, you get 4. They are prime factors that give you 4. Okay? The number 6. Well, what two prime numbers times themselves give you 6, Charlie? 2 times 3. Now, the number 8 gets a little more complicated because you might be inclined to say 2 times 4. Well, unfortunately, 4 is not a prime number, so you have to actually break it down again into Ava.
2 times 2 times 2.
Right. So the prime factorization of 8 would be 2 times 2 times 2. 3 prime numbers that times themselves will give you 8. Okay? Now please don't start sticking 1s in there ever. You'll never see a 1 in there because 1s, you could break things down by 1s forever and ever and ever and never get to the end of it. So 1 will never be part of your prime factorization because 1 is not a prime number. Okay? Now, what happens when we get to, let's do just a little tougher one. Let's do 24. Now, when you do 24, there are 2 methods to do this because we're going to start doing bigger numbers. One of them is the tree thing. That's that whole factor tree. Okay, the whole factor tree thing. And the reason it's called a factor tree thing is because when you do it, it looks a lot like a tree. Well, let's look at 24. What you do is you say, okay, what times what gives me 24? 6 times 4. Okay, these 2 numbers give me 24. I look at them and I go, are either one of them prime? No, they can both be broken down again, so I make another branch of the tree. 6 is 2 times 3, and 4 is 2 times 2. When you get to the bottom and there's a prime number, you know you can stop there. This is prime, this is prime, this is prime, this is prime. So the prime factorization of 24 is 1, 2, 3 2's, and 1 3. This would be the prime factorization of 24. You'll never have a 4, you'll never have a 6 in a prime factorization because those are not prime. You can break them down some more. Now you might be saying, but when you were doing 24, I was thinking about 8 and 3. Well, it doesn't really matter. If you do 8 times 3, you stop at the 3 because it's prime, but you still have to break down the 8. And the 8 you could say is 2 times 4. You can stop with the 2 because it's prime, but the 4 needs to be broken down. Again, it's 2 times 2. Those are both prime, so you can stop. You still get 2 times 2 times 2 times 3. Or maybe you were saying, I was thinking about doing 12 times 2. Now that's perfectly okay. You stop with the 2, but now you have to break down the 12 into 3 times 4. You break down the 4, it's 2 times 2. No matter how you do the factor tree thing, you're still going to get 3 2's times 1 3. And please, when you write them as your answers, put them in order because sometimes they'll get long and you'll get confused. If you put them in order, that's the way I'll read the answers and everybody will be happy. Let's do one long one there. Let's do, I don't know, let's just do 200. 200 can be broken down numerous ways. Annalise says, let's do what times what?
150.
Times what?
2.
Okay, 2 times 100. I can stop with 2. 100 is not prime, so I have to keep going. Philip says, break it and do what?
25 times 4.
25 times 4. Neither one of those are prime, so you can't stop those. You have to break both of those down again. 25 breaks into, you don't have any options here, it's just 5 times 5, of which both of those are prime. 4 breaks down into 2 times 2, and both of those are prime. So your answer to 200 is how many 2's? That's why it's a good idea to circle, because you might get lost on one if you don't. 2 times 2 times 2 times 5 times 5. I can guarantee you, if you remultiplied all of these 5 numbers together, you will get 200. Holly?
So do we always start, so you start with the smallest, then the factor.
You don't have to. I could have done 20 times 10 for my thing here. It's not going to change my answer. Matter of fact, it might go quicker. You won't have to break so many things down. Is that what you're asking? Are you talking about this part?
Yeah.
Yeah. Go least, go smallest to biggest, because that's how I read the answers.
And it doesn't always have to.
Yeah, it doesn't have to have a 2 as a prime factor. No, 9 would be 3 times 3. Kendall?
So you always have to use that number, like it comes down and then it's a prime number right away.
You mean this one?
Yeah, that.
Do I have to use that? Yes, I do. If it was something at the end of a line and circled and nothing comes underneath it, that's a prime number and you have to use it. Now, with that being said, ladies and gentlemen, that was one method. That's the tree method. The other method is called division by prime. You might like this one better. I don't know. And division by primes is just like it says. Okay, what you're going to do is take the number and you're going to divide it by a prime number. Okay? And the most obvious and the best way to do this is if it's an even number, just divide it by 2 because it's easy to cut things in half. For example, I'm going to divide 200 by 2. 2 is a prime number. I'm going to circle that 2 because it's going to come to play in my answer. When you cut 200 in half, you get 100. And then you look at 100 and say, what prime number can I divide that by? Again, it's still even, so I would still use the number 2. Half of 100 is 50. Okay, what number goes into 50? It's still even. I would divide it by 2. You don't have to. You could say 5, but just makes it easier. Half of 50 is 25. And then you get to 25. What number goes into 25? A prime number? 5. And then when you get a prime number here as your quotient at the end, you can stop and circle it. This is your prime factorization. 2 times 2 times 2 times 5 times 5. Some people like that better, some people don't care, some people it doesn't matter. Either way it works. The book will probably tell you to do it one way or another, and you should probably listen to the book, because the book is all wise, you know, at most times. How about, let's do 150. Let's do it by division by primes. If you're dividing by primes, what prime number might you pick there? Again, if it's even, I would go, Grace, with any even number can be cut in half, so I'd always do even numbers by 2. And hopefully you know that half of 150 is 75. Now I don't have an even number anymore. This is where the rules of divisibility are going to help you out. What number do you know for sure that goes into 75? Okay, 5. It's a prime number. Go ahead and circle it. 5 goes into 75. I'll just work with me here. It's 15. What number goes into 15? That's a prime number. David?
3.
3. 3 goes into 15 5 times. Once you get to a prime number at top, you stop. Like I said, don't start putting ones down there, because you can divide 5 by 1 from here to infinity, and you're not going to stop. So you don't need to do ones ever. Okay, so you end up with 2 times 3 times 5 times 5. Again, your call as to which way you want to do it there. Let me give you one to try here. Just sit there by quoting there, everybody will be happy there. How about this one? 60. You do 60 for me any way you like. Give me the prime factorization of 60. Any way that you like. Increasing or division by primes. Again, when you divide by primes, you have to divide by a prime. And Bailey says
2 times 2 times 3 times 5.
2 times 2 times 3 times 5. Did you use the tree or did you do division?
I did the division.
So you take 60, cut it in half, you get 30. Cut 30 in half, you get 15. And 15 is 3 times 5. Those are the numbers right there. Anybody have issues with that?
No.
Alex?
Oh, I noticed this thing kind of looks like a temple.
Yes, let's call it the temple. It very much looks like the
It looks like cake stick.